Suppose a certain HIV test has a sensitivity and specificity of 99.9%, and the test is applied to a population of 1 million people. If 6.6% of the population is actually infected with HIV, calculate the positive predictive value, negative predictive value, and how many people test positive who in fact do not have the condition. So to find the positive predictive value and the negative predictive value, we'll use these equations. But to do this, we have to know the true positives, the true negatives, all positives, and all negatives. To do this, we'll make a table and use the percentage infected and the sensitivity and specificity to find these values. So HIV, yes versus no. Test positive, test negative. And totals. So the total that have HIV would be the 6% of the population. So this number is going to be 6.6% of the population. So 6.6% of 1 million. That's 66,000. Those that test positive would be the sensitivity. So the sensitivity is 99.9%. That's the percentage that will test positive of those that are infected. So this number is going to be 99.9% of the 66,000, which is 65,934. What's left of the 66,000 are the ones that will test negative, 66 of those, of that 66,000. The total that do not have HIV would be what's left of the population after you take out the ones that have the condition. So if we subtract 66,000 that have the condition from the total population of 1 million, then we get those that don't have the condition. So this number comes from taking the total population and subtracting 66,000, the ones that are infected. That leaves you with the ones that are not infected, that don't have the condition. So specificity tells us how many that should test negative of the ones that are not infected. So 99.9% of the ones that are not infected should test negative. So that's this number here. This number is 99.9% of those that don't have the condition, 93,400. So 99.9% of 93,400, I'm sorry, this should be 934,000. So 99.9% of 934,000 would be 933,066. So these are the ones that test negative out of those that are not infected. What's left of those that are not infected would be the ones that test positive, which is 934. That's what's left if you subtract this number from this number here. Get this number. Okay, so the PPV was the true positives divided by the total. So the true positives are the ones that have the condition and also test positive. So that's this number here, 65,934. And the total of all the positives would be everything in this row here, all that test positive. So that's the sum of those two values in this row. So this simplifies to 0.98603. And if we multiply this number by 100%, then we get that the PPV is 98.603%. NPV, the negative predictive value, equals the total, the true negatives divided by all the negatives. So the true negatives are the ones that are not, that don't have the condition and also test negative. So they test negative and they don't have the condition. Those are the true negatives. So that's 933,066. All negatives would be everything in this row that includes those that test negative. So it's the sum of these two values here. So this, if you put it in your calculator, you should get 0.99993, pretty close to 100%. We multiply by 100%, we're going to get 99.993%, pretty close to 100% for a negative predictive value. Both the values, the PPV and the NPV, are high percentages. So the last thing was how many people test positive who in fact do not have the condition. So we look at the row of those that test positive. These are the ones that have the condition. These are the ones that don't have the condition. So this number is the number of the population that tests positive but does not have the condition, 934.